All right, let's look at the construction mode. I want to figure out how that's stored in memory and where that's located. So let's take a look. I guess we'll have to look at game mode. Perhaps that's different for construction mode as well. We have 0 meaning type A and 1 meaning type B. So I'm sure construction mode is perhaps mode 2 or something. So C81A is our target here. Oh yeah, I already figured that out. Let's go there anyway. Where are we? 81A. That's over here. This guy. Let's go in construction mode. Yeah, that's 02. And it's going to affect when we start a level. So we are definitely reading this value when we actually start a level, right? So let's see when that value gets set, or not set, but read. So I'm going to use this level, that's fine. Maybe put the exit a bit closer. No, not here. I'm going to put it here. Well, no, that doesn't really make a difference. Good, let's see. I added a button here to add a watch point straight from the memory viewer. That makes it a little bit easier for me. So now I have this thing, like I add it here, I immediately get it here. That's a bit handier. I do want a read memory, and let's play this game. Of course, it's going to read that stuff like all the time in this mode, but yeah, like every time I move, it's probably going to read it and update it perhaps. But I'm guessing I can simply continue now. Yeah, so let's see. So it is indeed compared to 2, which is already interesting, because that's actually checking for is construction mode, and we're going to play a sound 8 after that. It's probably a different sound for construction mode, perhaps, not sure. Let's see what happens. So we're not checking it anymore. Now it's okay, the music is playing now, sure. I don't have it on in my earphones here. Again, checking, show main menu, that's also weird. I think that's the wrong name here, like that's not going to be show main menu, because it's going to jump away, I assume. Yeah, it's not. So I added this to where it shows you whether the jump is going to be taken or not. Of course, that information is available in here, as in it's a conditional jump based on the 0 flag. And it will jump if the 0 flag is set, which it isn't. But to avoid having to like remember all that stuff and keep reinterpreting it, I've just painted it red if we're not going to take the jump. It's a new feature that I've added for myself here first, so I'm not sure if it's 100% correct, but like, yeah, it does seem to work, at least for this one. So we were going to jump away if we weren't in construction mode here. That's interesting. Okay, so let's continue. I want to load the level though. So now we're checking again the game mode, but that's fine. I mean, it does have to get checked multiple times. Okay. Initialize type B treasures. That's not going to be the case. I think I've already jumped too far though. Like, okay, that's the demo game mode for recording, which is also interesting because why would we well, no, of course we record the custom level as well, right? Yeah. So that makes sense. And then it's the stamp collisions based on, well, that's not gonna, yeah, so that return is gonna be taken because this only applies to type B. Okay. And okay, now we're in the continuous loop of on the game loop, right? So that's going to be checked lots of times. So that's irrelevant. So what I need to do is stop earlier, I guess. I need to see where the level is put in memory, as in we have to have like the map stored somewhere, right? Also, I think you can do multiple perhaps. No, I need to control stop. I don't think I can hold control here. Yeah, no, it's I have to control like this and then stop. So I go back to the menu. Yeah, so indeed at the right side here, I can do round 1 to 5, I think. No, I have to do select. What was it? Yeah, select button, I guess. Yeah, so I can I not increase the number? It's a select, that's not it. And then, I mean, that doesn't do anything. What was the other one? Was it control select or shift select? No, let's go up, okay. Okay, I can't remember the thing to the key I have to hold. I thought it was shift though, like what? So if I go here, I can move here, and with shift I can move here, right? So why would that not be the same? Unless, well, it's the same menu as Filer though. So if I go shift select, I go up. Yeah, so it remains here based on what was last selected, either the filer if you go down or field if you go up. But I thought I could change this this number here, and apparently I can't, because unless it's 2, yeah, of course it is 2. So yeah, we have different levels here we can load. Well, the 5 first ones, because 6 doesn't work. So they have to be stored somewhere, right? So that's the point, I guess, to figure out where that is. I mean, I can start putting stuff here in the level by going to field and like putting something here. But the question is, of course, where does that get written? We have our map. Not the power-ups, but I think I called it level data, level map. No. Oh, the tile map, perhaps C81E. Right, so this is the map. Let's see if that gets cleared. Yeah, so this doesn't budge at all. So we're not writing this definitely in this piece of memory. This was the, well, this is another map, but also not related to construction mode. This is the water flow direction. Right, so also nothing here. Yeah, nothing's moving. How can we figure that out? Okay, I know. Let's first start with this number here. Let's use the cheaty thing. Where was it? The cheat finder to find the number here. Maybe we can find that. So start a new search for subject for 1. Okay, and now we will go to 2. Oh no, we have to go to the correct round thing here. We go to 2, and now see if we can find 2 here. Yes, so D97C is our construction mode current index or round index. So if I change that, what is the next one here? Oh, arrows and bridges, okay. So if I change that to 1, does it jump back? Oops. No, it does not. But it does get overwritten though, like that is the construction mode level, or round, I guess, as they call it. I mean, I can't force it to do another round, so it doesn't update either. So it's just the result of swapping out the current level. Okay, we're gonna give that a name though. That is D97C. And that is construction mode current round. Okay. So you would have expected that other construction mode stuff would be like in this vicinity, right? So we have some empty data here. What is the previous one? The password screen, top box, border color. That's, well, sure. But yeah, we have some Fs here. And then the next map is the map data for the arrows and the bridges. And we have a second map here for the inanimate objects. Okay, so we are near the maps though. Oh yeah, so this does change. Oh, okay, that's good, that's good. So, I mean, oh yeah, so our inanimate objects, this is literally the map, so... And this is the current one, right? Because if we change, we have to save this, right? Because we have 5 rounds, but if we start, this will be overwritten, so it has to be written somewhere else as well. Right, so, but definitely this is the pointer that's being used to edit this. It just gets saved somewhere. I have to reload here. Okay, so we have our current round. Do we see our selection here either? Let's see. If I go... Oh, that timer is being used too, no? So password screen... Oh, that's not only for the password screen. That this timer is for these flickering rectangles here, like this. They cycle through all the colors. And we have to use these timers for that. So it's not only... Oh, and I have 2, right. We have 2 here as well. So in the password screen there are 2, and in construction mode there are 2 as well. So yeah, these are being used as well. So I mean, I can't force this value because it's it changes too quickly, right? So yeah, this is for password screen and for construction mode. So oops. So does it copy into D920? Yes, it does. Oh, but that's incorrect though. This one doesn't count all the way either. Oh, but I did force the value, so that's not good. Let me escape here. And okay, that's fine. And let me escape and go back into construction mode. And I'm assuming no, it is still counting to 15, I guess. Let's see. So yeah, these are just the timers for the borders. So this is not necessarily password screen. This is for a, how do we call this? Like a color changing box. And this is box 1 and 2, right? Because the bottom and top doesn't mean anything, because over here they are side by side. Well, so I mean, they are copied, but that is irrelevant. I mean, it's only incrementing one and then copying it to the other one, so they are in sync, but that's irrelevant for, like, that's just a little rotating timer. These, or I guess I can duplicate the comment. This box is used on the password screen and the construction mode. Okay. And then we are at least in the area, in the vicinity, through with our little construction mode stuff here. Do these values change too? Yes, they do. Okay, so they made a system to put these boxes on the screen and store their positions, and that same logic is indeed used for the password screen and for construction mode. Because for the password screen, you can choose like entire sprites, like pick out all the characters, right? And this is of course the same thing, and they are using the same logic for this, and even same memory locations. So we don't use this one though. That's weird. So we are seeing an update in these guys. Password screen next entry slot. That doesn't make sense either now, because this looks like an X value. Oh, and this is a Y value. Yeah, that's a mix-up, right? Because this is 1, and well, I can go to Y13579DF. Okay, so that's definitely Y, and that's X. And what is this 3F? That's Y coordinate big. That's a bit weird because it doesn't match with what I'm seeing in the password screen. That's interesting. So let's see. So this one was unnamed, but this is our Y for sure. Like this goes up and down, and our X is the next one. So let's go to the password screen and see how these values stack up with what we're seeing here in construction mode. Right, so we have, now it's these guys that change, and that's why, yeah. And this one does change for the password screen, but didn't for the construction mode. So I guess these two are Y and X for password selection, and these two are Y and X for construction mode. I mean, they could have used the same ones, of course, like they are not going to interfere because these screens don't have a link, right? Yeah, and this one then also changes, I guess. Do we have, because that one has to have a position as well, right? So that's, wait, did my thing change? No, so the top one doesn't change, so these two stay the same. And oh yeah, this would be the second box then, Y and X, because that one increments, right? So the D becomes F. So yeah, that's the second box. So it's first box, second box. That would mean that in construction mode, this one was the left box, and this would be the right box then. So let's verify that. Can I not stop here? No, I have to continue. Okay. So yeah, these guys are the left box, right, down and right, and then this would be the second box here, the rightmost box. Wait, I have to do shift move. Yeah, absolutely. Yeah, so that was a bit confusing, but these are just positions, XY positions. So let's look those up. That would be, so we're looking at D915. Yeah, that's this one. Color changing box 1. I guess they were well, no, they're the same order, I mean, as the colors. So color changing box 1Y, and this is X, and then we have the two after that are for the second box, D917. Okay, and so this is wrong, right? This is next enter slot is wrong. That's just the X of the second box. Let's reload that. Right, so we have two YX coordinates, and then we do have 3F here, and I don't know what that is. That looks like a third coordinate, but not really. When does this change? When I change, it changes when I change the rightmost, which is the first one here. That changes, but the 4F changes as well. And it's also an XY coordinate because both change depending on which way I move. So to the right, left, ED, ED, and up, down, 4, 3, 5, 6, 7, F. So they are related to box 1, but with a different value. That's quite interesting. Why that would be different, or why that would be, how those are related, I'm not sure. But this would be, yeah, chord big. Yeah, that's really that, right? So it is about box 1. And we don't have that for box 2, right? Yes, we do. Absolutely, we do. It's these guys here, and they're in the same struct. So yeah. So we have. Oh, this might literally be a. Well, I was gonna say maybe it's a tile index, but no, right? Because that they changed based on position. But yeah, so we have a struct of like Y, X, something, and color. And then we have another of these structs here. So this is again a struct for box 1 and a struct for box 2. Simple as that. But I don't know what is 7F and D0 though. That's 127 and 208. Like they can't be because they change, right? Like it can't be a sprite, right? Because no. Oh, are they? Wait, let's see. 7F is 127 and 208, and where I am looking at the rightmost box. So let's go all the way down. That's now AF, which is 175, and the upper value is 63. So I'm at 175 now. But yeah, this is not sprite related. Like this one here, oh yeah, no. It is X and Y in sprite coordinates. And the other one was tile coordinates then, I guess. Because let me go, so that would be this one. Yeah, that's 02, 01, 02. I would have expected 02, 04 because that's what it is in the game, right? I don't know why it's now 101, 02. That's a bit unfortunate. Like, why would that be a different coordinate system here? Because yeah, the top left position is 02, 04 here, and I can't go any more left. Like, no. Okay, so let's see. I mean, I'm hesitant to call it a tile, but I guess we don't have anything else because we are using this for sprite, right? So this is sprite Y and X, and then we have the border color. I'm gonna put that in front of here. So yeah, first we have 4 coordinates, like 2 each, and then we have a little struct. First the sprite Y and X, and then the border color, and then we have the same, well no, we have an unknown, right? In between, yeah, the B is unknown, so that's unknown. I mean, I shouldn't really define it if I don't know it, but... And then we have the same for box 2. All right. Oops. Why are they not loading? Box 2 should be... Oh, no, okay, overwritten. Okay, no, that's D, E, F, and 2, 0. Yeah. So the unknowns are these guys here, they stay on 0. Because is that like, I mean, I'm assuming it's a sprite or a tile ID. Because the structs come, like, they're the same as all the other ones we've seen. Like, for example, low position Y. So we have a Y direction. We do, no, we do have a direction and a sprite though. So no, it looks to be like a different type of struct at least. So yeah, I'm not sure. We can of course check whether that value is read or written to. Let's add a watch point here. Yeah, so I'm moving both boxes, and this value isn't written to, nor read, I assume. Oh, it is. Okay, that's given to a port. What? Why would that be the case? So DE is pointed to D91B, and that's written to a port. Wow. So let's look at the out instruction again. So out the destination of 89. I'm not sure if we're gonna find out. Yeah, so the value of A is written to port N, which is 89 hex. I mean, I don't know if I can easily find that. Let's see. Well, port. Let's see if the... Oh, writing data into VRAM. Why would that be done like that, though? Oh, we're quite low. Okay, no. We're low in the... We're in the BIOS here. I didn't see. So this is right into VRAM. Okay. And can we jump out of this to see which function was calling us. No, we cannot. I mean, although this does call some stuff though. As in, this looks like, I mean, this looks quite high, right? So within 9,000s here, this looks like high enough to be in ROM. So yeah, maybe we are here. Yeah, I mean, yeah, because we're loading in this unknown here. I've seen that one appear more times as well, which set this to 0 here. But we're not in a known function though. So unsure about this. But it is at least read. So I'm guessing this struct is being given to the VRAM. And then we, of course, we don't break on anywhere else, because that byte only gets read when we're actually moving that memory into VRAM. It's probably going to be the pointer before that, like the Y that contains the entire, a pointer to the entire struct, that will then be assigned to the VRAM. So if I put a what point on this one of read, then we will probably see the, well, no, I was going to say that we were probably going to see the write to VRAM instruction, but apparently not. Actually, no, we're in the same spot. Yeah, I think this just stays on 0 because we have to perhaps write this little struct to VRAM, and it just has to have a value there, which is irrelevant for this sprite box, I think. So yeah, it doesn't really matter. Let's see. So do these guys move? And we have a couple here as well. What's this? Exitor index. So that is right. It was an index. This might be map data too. No. Let's see if any of these guys change. If I put stuff here, like of course the positions increment, but that's because I'm moving this box. But yeah, for the rest, nothing changes, right? Okay, oh, right. And now let's look at the menu change. So if something else changes here when we move around in the menu here, so let's take a look at that. Where's the keyboard? Select. Yes, these guys changed. Wait. No, they don't change anymore. Does it matter if I change these or these guys? Yeah, they get reset to something. Oh, is this because this perhaps? No. It's not the selection here. Well, no, because that would have been the index position, right? We do have the YX position, so we know where we are in our selection here. But it does get changed based on where we were. Like, what? That's weird. See, now it changes too. So if I keep going, it doesn't change, right? And if I change this, no, how do I, oh, shift arrow, I guess. Okay, so that's menu index, the first one there. 1, 2, 3, 4, 5. This one here, I mean, that's the menu index, apparently. and this is saved, so we're on 2 now. Yeah, that value that is saved, and it should remember. Oh no, it defaults to 5. I guess it defaults to clear. I don't know why, but sure. Yeah, so D914. That would be construction mode filer menu index. Okay, that's this one. I mean, we must have different menus as well, though. How do we do this? No, I don't want to do this. I want to go to save and then perhaps shift select. Nope. I don't remember the enter. Oh, yeah. Okay, here we are. This completely changed now. So I wonder if this changes with the regular level too. I think it does, though. Yeah, so we saved the level, and it actually did make some changes here. That's quite interesting. Let's see what happens if I load. Okay, so this changed. I don't know what is loading from, like a device that's like a cassette tape, right? So I can't really test that. When the file name has to be input as well. Let's see, select, no. Oh, are we in something else now? Wait. So I activated load, and now I can't move anymore. Select doesn't do anything. Okay, so I think I'm manipulating something here, but it doesn't let me move out. Or maybe it is waiting on tape, of course. I don't, yeah. That might be the case. Yeah, I think it's stuck reading the tape. Okay, never mind. So let's not read on the tape. Let's go to the filer menu. And can we change the device? Are we? No, we're not stuck. But I mean, I don't remember how to do this. That sucks. Like I can enter. Well, it's space, no. Because I need to be able to, like, if I save, for example, I do need to be able to put in a file name, though. And one is files. F6. Is this the file name? It doesn't change, at least. 20, that's 32. Are these asterisks? Is 32 an asterisk? Tile viewer 32. Well, 32 is nothing, and then 33 is a red asterisk and a blue asterisk. 33 and 4. And they are on 20, so 32 is nothing, though. So what if I change that to, it's +1, so 21 is red, 22 is blue. That doesn't change it. But it's or it reset it as well. Like it's very suspiciously, like there's six positions here. I'm pretty sure that's the file name. Wait, so let's see if I can. Okay, so that doesn't change. I don't remember this, and I don't think that's like explained in the manuals and stuff. Like these walkthroughs don't have that information. Okay, so left shift and arrow key causes the cursor on the menu to move. We knew that. The selection key chooses between different menus. That's also known. Okay, so we have those guys, power filer, save your rounds, load your rounds, change the device between disk and cassette. But how? It doesn't say how to do that. Check files of drive. Yeah, so it doesn't say how to actually put in the file name and stuff. It might be connected to what is available as peripherals on the thing here. Oh, we do have controls for that though. Can I? Okay, I mean, sure, I can record a WAV file. That's cool though. Of course, I don't have a tape inserted. I mean, I guess we can try to save this to a WAV file, and if I think I have to do them both, right? So no, I have to record. So is it now recording or not? Or does the thing have to initialize that? Yes, it does. Okay. So once the ROM says start recording, then it actually does. I don't know how long it's gonna go for though. Like I'm sure that's done already, right? Yeah. Well, I mean it stopped when I moved. That's also interesting. Okay, so now can I load? We didn't give it a file name though, or is that only for disk perhaps? Right. So wait. So can I stop, rewind, and play? Does it then load this stuff? Because I can't move anymore now. Like it's loading, but I don't know what it did. It did. So it does load the entire tape, it seems, but it did refresh the level. So it did save this level to tape, so to say, to our WAV file here. That's quite interesting. But I can't change devices for some reason. I don't know why. I mean, it's probably because like there's no thing connected here, right? No disk drive. Oh, right. No disk drive is present. Can I do that? Okay, I'll have to look into that because I have to select an. Okay, don't go away. I have to. Okay, that's a bug. I have to select like a tape or a disk drive, right? And that's why I can't change this thing here. I only have a tape deck available, and I think the file name is going to be related to the disk drive and not the tape deck. Okay. Good. So I'm going to put this as the file name though, because that looks too suspiciously like the file name. And these things after here, they change as well. Every time I do save. Yeah, that became 39 now. Okay, I have to record, I guess. Yeah, that became 39. And if I do load, it becomes 37. So it's definitely related to tape and reached. Okay, sure. Definitely related to save and load, but not sure what it does. So yeah, so D926. I'm gonna say probably because I'm not 100% sure. I'll have to install that disk drive first, so I'll do that separately. So probably construction file name 1, and there's 6 positions. 3, 4, 5, 6. 6. Okay, and then we have, I think it was only this one that moved though. So let's see if it's okay, I have to reset again, I guess. I might not have saved the entire level, so it probably broke in the middle. I don't know if this one moved though, or if this one moves in a different menu. So 37, I'm pretty sure it has to be the filer menu. No, select. So 37 is standard. Yeah, it's like, okay, oh, is control messing here? Yes. 3B. So it does change, but yeah, of course now the tape is incomplete. That's fine. So this is filer related, but filer load save related, I guess. Yeah, because this doesn't do it, and this does change it too now. Okay, so filer related, that's D29C. Wait, that's not possible. D926. Oh. Oops. Yeah, it started at D926. And then this one is construction filer related. Okay. Let's reload that. Okay, these guys are interesting too, though. What else do we have? The current round we had here, so that's fine. Does this question change anything? Ooh, there's timers running. Why are there? So these are the box timers, right? The box color timers are running for some reason. That's interesting as well, because there's nothing, like they're not on screen, right? That's curious. I'm gonna say no. Nothing else changes, right? I mean, this one changes here, but when I press N, but only when I press, well, and I'm assuming yes as well. Yeah, so that's, and it doesn't do that now, only when this is active and this is running. Does that change? Why would it be so far away though? That's weird. I mean, I guess we can give it a name, but it's probably not related to just the construction mode I'm assuming it's going to be related to something else as well. So for example, if I go to the round number, does this one light up as well? If I go to round, yes, it does. I mean, question is now, like, is that used elsewhere or just for construction mode, right? And it's debounced, it only flickers like one and it immediately goes back down, even if I hold down the button. Well, the debounce runs like multiple times, sure. Is there another spot where we have to enter something? Let me see. In the, well, no, the password screen, well, that has a space though. So let's see if the password screen space also lights up this this value here. No. So that's, yeah, okay, that's entered password. Yeah, no, so this one doesn't get doesn't light up, and if I move it, neither, that doesn't change either. What's weird though is that this is still set to 2. That's also, that was, well, I don't know why that is the case, but sure. So yeah, this has something where we have to input some values, but, and in the gameplay either, no, gameplay has no thing. So it is for construction then. It has to be a key debounce or something. Wait, let's see if we can see something in the code at that position. So let's put a right breakpoint on that. Oh wait, crap! I already pressed spacebar. Did it work in the menus as well with arrow keys or spacebar perhaps? So no, neither here. It did flicker when we loaded the construction mode, but yeah, it doesn't light up except when you are asked this question. No, enter. Like now, if I press N, it does light up. Okay, why? Okay, because control is held. Right, so it does light up. I mean, I can give it a name though, D87. Oh no, we're going to look in the code. Wait, let's add a watch point for writing to this value, and then let's see where we break. So here we're putting 0 in it. Okay. So something else wrote a 1 in there though. Unless, yeah, no, we might have jumped here. Okay, no. Jump, that's BIOS level. So this X or A would have canceled it out, but I guess we are jumping here straight. Do we from somewhere here? I don't see anything. Like we can check it, of course. So this shouldn't break on the XOR, right? Because we still have 1 in the accumulator. And we're already past the writing into the value. So if I go run again, now it's okay, now it's 0. Wait, why did it clear? Did I not press N? I can't remember that. Oh, no, of course, it reset. It reset. Okay, so now I'm gonna enter again. I'm gonna press N. Yeah, so we didn't clear it out. Okay, sure. So we must have jumped here for somewhere. Can we see a 9A6F? That would be a call then, 9A6F. Yeah, we came from this call, 9AC8. Yeah, that's the one. So that means that that's a little function then, I guess, that either debounces the key or something. Because we return here. It calls a very low BIOS function. So let's look what that is. It's probably input related though. Let's see. No, I want the BIOS calls. So we're calling for D. Write data in VRAM though, not what I expected. Unless it's like an update thing, where because the text has to be removed, right? I do wonder though, when are we writing 0 in there? So let's see if we do happen to jump on that now. So again, writing, no, now we're writing a 0 in there, but the 0 doesn't come from this one. The 0 comes from elsewhere because the accumulator is already 0 and we broke here. That's also interesting. Wait, why are you breaking here though? I think it's a bit confused. No. Okay, so we break here. And next time. Okay, but no, that's not possible. Okay, wait, did I? So let's disable the, oh no, these are the guys I've added. Oh no, it's the, okay, it's the watch point that's messing with me, I think. So now we're writing 0, okay, and we're back. Okay, so now let's see if I go again. We immediately go on the second. We have 1 in the accumulator. But yeah, the 0 doesn't come from this XOR. Okay, I guess. So we're coming from 9A76. 9A76, that's from this call. And here, okay, here we're clearing it out, sure. So the question is, what is it like? Is it a debounce thing? Like over here, we're putting 1 in it and calling this function, and then over here, we're putting 0 in it. And we're loading this pointer. Right, because if you look at it sequentially, we are activating this value, doing something, then loading the, oh, we're doing this twice though. Oh no, wait. So first we're doing the arrows and bridges, and then we're doing the inanimate object. So for some reason, it has to be held high if we're loading arrows and bridges for some reason. So what does this function do other than putting 1 in this variable? Right, it said it put data in VRAM. So let's see what it puts in VRAM though. Oh, and it's in a conditional call as well, which we're not taking here, because if we jump in, we're not jumping in, right? So we're not putting something on the screen. Okay, so we're doing a check, that's fine. And based on that result, so we're checking whether A is 0, right? So D875 is also something, oh no, that's, okay, that's our value we're looking at. So we're checking whether that's 1 or 0. Okay, and it's 0 now, so that does make sense though. If it's 0, then we're probably not doing anything. So let's see what happens if we have 1 in our thing here. Okay, you can go away. Wait, so are we running? Yeah, so it's gonna be more interesting when it's 1, of course. I am pressing no though, so. Okay, so 1 is in the accumulator, and we're saving that in D875. So yeah, that's here. And then we're loading our base, and 16, so 32 bytes, I think, are copied. We're loading that in the accumulator, but that's still there though. We're checking whether it's 0. We're loading the value of D97D. D97, is that here the pointer here? Yeah, that's the, okay, that's, okay, sure. That's the one we were pointing at that we were given, right? So where are we? Yeah, that's this pointer has been loaded into DE, and next time the inanimate object pointer, which is a bit lower here, will be loaded into DE, and we're calling the same function. Okay. So, okay, so we're loading that pointer, that's fine. Wait, no, we're loading what that is pointing to. D97D is pointing, that's like the first, could that be a count or something? Because that's like the first byte gets loaded in the accumulator. That's also weird. Because, and then we're doing a conditional jump on that fact though. To 980A, so we're skipping this test for some reason. Okay. Right, so we're skipping this and which would affect the fact whether we call this or not, right? So, but we are calling it, and what are the parameters? So I have to look again at the BIOS call here to see what it exactly was. So yeah, we're writing at HL. No, that's the, wait, yeah, that's the address we write to, and we're writing the value of A. So there's no length, it's just 1 byte. So we're writing a 0 at HL 1822. Okay, so 1822 was the name table. Okay. Is this for sprites? I can't remember. I think it's sprites, right? No, that's after, that's before this one. Okay, so it's tiles, I guess. Neither this one, no. Okay, that doesn't really matter. We can see what happens though if we remove that call, which is what we're going to do next. So instead of messing here, we are going to look at this one, and we're going to remove this one here. So let's make a copy of the ROM. No, not this one. Okay. And then we get the hex editor. What am I working on? We are working on figuring out what happens in memory with the construction mode. So everything related to construction mode, where you can make your own level. That's what we're looking at. That has to be stored in memory somewhere as well. And then I'm just seeing where I end up, seeing what memory we see moving around, and figuring out what it does. So, but yeah, the focus is on the construction mode now. Seeing what that does. Okay, so let's search 117DD93E01CDC89A. That occurs once, that's good. And we want to load, so 3E01, we're going to load 0 in there, meaning it never gets set to 1. So yeah, we save that. Let's load our hacked ROM. So we're applying the hacked ROM. We should disable our breakpoint here. Reset the machine. And now we are in our hacked ROM. Let's go to construction mode. Okay, that does quite a bit. Is this the rendering of the background then? Like the clear? I mean, it could be like simply clearing the screen or something. Because what happens if I clear this? I mean, this does work, but this doesn't. Okay, so clearing works, but I can't put anything. Oh, is it because it already is a... Oh yeah, sure. Okay, can I only paint on empty tiles? Okay, no, that works. So let's go to that menu. Wait, which one was it again? It's this one. Yeah, okay, clear. So, and it happened when I did N, right? Yeah, so it's a clear screen kind of thing. So that would imply that if I always put it on 1, it would never paint anything inside the level. Because now it doesn't clear, so the 1 actually means should be clear level or something, right? So let's see. Can we force this value to be 1 all the time? It's this XOR, right? So we're going to reset this to 1 and then remove this one. So I only have 1 byte available to write, so I can't write 3E01 here. So I guess we're going to just have to knock this out. And assuming it's always going to be 1, yeah. That would be, was it this one we changed? 3E, yeah, it was this one, right? CD, CA9A, okay. So I'm putting this one to 1, this one back to 1, and then our AF here, which is this one, I'm gonna remove, right? Can I, yeah. So we reset this one to 1, and this now is gone. So now it should stay 1 all times, at all times. Right, so now it paints, no, I did that. Wait, let's reset, because I'm not sure what happened now. Yeah, so it does paint, so that does work, but yeah, I mean, it has to do with clearing the screen, but apparently it's not like it always clears all the time now. I mean, it does make sense because that function only gets triggered when I press the N key, right? So that's like, of course now I pressed yes, but yeah. Right, so okay. Let's look at that value again. So that was so we're calling 9AC8. So D875 was this one. Yeah, so it's hard to give that a name, but we can try anyway. D875 would be here. So this is construction mode. It should clear screen, I think. And this is held high when, although it has to do with like it has to do with these 2 pointers though. Like that doesn't make any sense. So we're loading the arrows and bridges pointer, and we're loading the inanimate object pointer. Wait. So so that is true, but what happens if I don't do this and I have arrows or bridges in the level? Well, we did that. Okay, so let's add some more just to make sure we're doing the right thing here. Wait, and I put it on, I'm actually doing this. So I'm disabling the inanimate object ones, which didn't have any effect. So let's go back. Let's put this on. I don't remember what it was though. Yeah, that was the instruction for XOR A, which I can't remember. So can I reload or have to? Yeah, I can. Yeah, so AF, and it was this one. So let's put that on 0. So now this one is always 0 now. It's never put on 1. And it should have an effect on the arrow and bridges pointer, right? Because that's what we affected now, as in the sequence of these calls here. So let's see, can I clear now? Where are we? No, I want to go here. Wait, did we crash or something? No, we did not. I want to clear. No. Oh, now that doesn't go away. Was that the... Yeah, that's what we saw last time, right? It doesn't clear. Okay, now I want to see what happens when I add some bridges. And it was bridges and arrows. So no, oh no, that's water direction. Those are arrows. Yeah. Okay, let's see what happens now. Now we have bridges and arrows, right? What is relevant for this thing? So let's clear. Okay, the text is still there. Okay, so I click no, and they aren't clear, but they shouldn't be clear though. Like that's perfectly fine. So yeah, that doesn't have a change either, because if you can look here, this pointer is what's being referred to, right? Yeah, level init map data arrows and bridges, and that's this one here. In other words, this pointer here, and that points to this struct of data, but it doesn't seem to affect it. At least holding that thing low, putting it on 0 doesn't affect it apparently that much. Is it because you can put Lola over a bridge? Let's try that. We're not broken. No, I want to go here, and I'm putting Lola. No, I can't put Lola over a bridge. Can I put water underneath this? Wait, does that work? Can I put... No, I can't put a bridge over water, so you can't overlap them. Okay, no, that does make sense. Yeah, I mean, I'm not entirely sure. Okay, that's fine. So yeah, this stuff here interests me because that is what I think is level data, not in tile form as it is here. This is in tile form, right? As in you have 4 blocks, like 60, 61, 62, 63, like they're in a square, but the width is wrong for them to line up, right? But I think this might be related to actual... I mean, it doesn't make sense. It should have more zeros, right? Because we don't pretty much have nothing on screen. Okay, wait, let's reset to our regular unhacked ROM. So let's go to construction mode here. Right, so yeah, these guys here, they change. So if we go to load a different round, do these change? Okay, so this triggers with this button press 2. So yeah, that doesn't change. That's weird, because I thought that changed with saving, perhaps. So let's go back to... Oh no, I need to go here and then... Yeah, so once I save, that changes. So is this the representation of the level on tape or on disk? For that to be certain, I need to like actually install a disk drive. I mean, I guess I can do it though. No tape deck. So what do I have here? Okay, but it sucks that it removes this like external disk drive. I mean, oh, I don't have those ROMs or whatever. I think so. I can't add that just now because I need just to add one here. Yeah, it couldn't find a ROM for that. Okay, so I need to find those first before I can test that. But I'm assuming, considering this all changed, right, that this is a binary representation of the level that gets written to disk. Could that be the case? Well, I mean, of course, if it's all zeros, now if I go save my round now here, like everything is empty, right? I'm loading all levels here. If I save now, would that make it all zeros? No, it does not at all. I don't think it even changed anymore. Oh, okay, so it doesn't want to change. Okay, sure. It can't save because I need a Lolo and an exit door. Okay, sure. It wasn't even saving, sure. Do I have to do that in every level though? Well, we'll see. Yeah, okay, sure. Give me some work here. So level 2, we go to the field, we're adding Lolo. I mean, it would be good to put him in the exact same position, of course, which I didn't do, but sure. Round 3. Select. And then go to round 4. Select. And go to round 5. Okay, now I can save. And I will look at this area here and see what changes, if anything. Just pretty much nothing. So it's not a representation of the level. Well, I mean, I didn't change much though. Wait. And it did allow me to change though, yeah, to save. Okay, so I can only see drastic changes. Of course, I wasn't looking 100% either. So if I make a drastic change by doing this, and now I save, does it change? Yes, absolutely. Yeah, I think this is the binary representation of well, the first level only stopped here, right? Which would make sense because we're saving all 5 levels all the time. So how long would that be? I think from here to here, perhaps. And it needs to save the power-ups as well, right? So they have to be in there as well somewhere. But yeah, those 7s do make sense. And then we have some stuff in between, which is the Lolo and the exit position. But we need to save like this. It's like it's compressed, right? It has to be because we have 11 by 11 positions, which is quite a lot. What is it, 121 or something? Yeah, so we have 121 pieces of data we have to save. So we are compressing that. Question is how. And also I'm going to try to see if I can figure out where the power-ups are located, because there's always going to be like some meta information, right? Of which the power-ups are one. Like that's one of the okay, so we have the arrow, and then we have a number as well. Okay, how do we do the number again? I thought I could do a wait, that's weird. Like I forgot how to do the number. Like at the side there is 00 now. What's the key to I did do this before though, weird enough. Oh, and also we are changing level round 5. I didn't see that before because we were looking at the start here, and I would have assumed that round 1 came first and then 2, 3, 4, 5. But apparently we're changing round 5, and these first guys changed. Unless, because the first 4 ones are pretty much empty, it is, they are in fact here just compressed perhaps. Like it started. Yeah, I don't know how to. Why does it not do those numbers? Oh, of course, stupid. You need to have hard framers in the level to be able to up that number. Of course. So we need to go here. We need to, like 5 or something is fine. Yeah. You need these guys in the level, of course, obviously, because otherwise it wouldn't make sense. Yeah. So 5, 4, 3. Let's save this. And let's see what changes, if anything. Yes, it definitely does change. I don't see my 1, 2, 3 though. So yeah, this is difficult to figure out. I mean, I'm pretty sure somebody did figure it out already though, how those levels are saved on disk. I mean, we can take a look and see if we find a routine that saves this. So if I press enter, so that's not apparently the first one, the first byte. Oh no, it's, wait, yeah, it's this one. So apparently it doesn't start here. What is this? Current map data exit or index. Okay. Okay, so maybe the next one. I'm just figuring out where it starts, right? If I press save, it doesn't break, so it's not that one. Nor that one. It's going to be the first 7, I guess. Okay, that's the first one then, I guess. Okay, so D895. This one is reference to. Okay, that's interesting as well. So okay, so we are at this guy here is the first one we are writing in. DE is D895. Yeah, that's that one. So now you have to see where we come from, right? Do we have a start of a function? We could be starting here. We have a little loop here, A442. Oh wait, yeah, A442. That's quite far away. That's down here. That's bizarre. So maybe try breaking here and see if that triggers the save. I'm going to remove the watch point, so it's the This one can go. And this one was the one that triggered. That's our breakpoint. Okay, so let's see. Okay, so we're continually breaking in this one. And I'm assuming that we will end up at our location where we were looking though. So let's see. Yeah, it was this. Yeah, okay, sure. It was this function, sure. Let's see if we can escape this. Call A415, sure. We return here, so perhaps we. Oh yeah. Here we are loading D895 into the DE pointer, so that's the start of something for sure. And I'm assuming that is going to be our save function, perhaps. Let's see. So we are not breaking there continuously. Why are we not moving? Is it waiting or is it something else? No. So I press enter and I break here immediately. Let's see if I can move out of this one. Yes, I can. But the question is this a named function here? No, it doesn't look like we have a return here. So this is the start of a function. And we have conditional return here. This might be prepping though. Although we are doing some stuff with oh no, tile Y. Oh no, that's okay, sure. That's the color changing box though, so why would that be irrelevant here? Also, we're copying that to another unknown that's close by. Oh, that's 9, 2, and 4. That's these guys. I'm not sure why we need a copy of that, but okay. Well, I mean, it's Y and X position is getting copied, right? Then we have a jump. Okay, wait, 9979, that's quite a lot. Okay, no, that's an unconditional jump. So maybe we're not in this function. It might start here, perhaps, because we have a conditional jump here as well, a conditional return here as well. So yeah, I'm gonna have to go up, I guess, to figure that out. C1E8, that is code, or I think that's code pointer. I see. Oh well, maybe not. That's this guy here. Wait. And C16E. Wait, what is this? Sprite pattern table that will be copied to a VRAM. Okay. C1E8. Oh, that's no. Okay, that was it. C16E. All right. So could this be like the level data that we have to, like that this function will compress? Although we're calling A3A8 multiple times, and at the end we call A3CA, which is what we are looking at. A3A. Oh wait, A3A8. Oh no, it's one of those fall through things. Okay, sure. So call A3A8 calls A3CA, which is the one we're looking at. Okay, sure. Okay, so let's see if we can break here, right? If we can figure out the start of this function. This is an unconditional jump, so perhaps we start here. Let's see. Yeah, so this one is called multiple times, which also makes sense because we saw that literally here, right? Like there's multiple calls to this function. So that's not really relevant either then. A3CA is going to be disabled. Yeah, so I'm just trying to figure out the top of the save function, right? So we're going to have to select again because it's a bit stuck, is it? Still? Yeah, now we're here, okay. I'm going to save again. Yeah, we do end up here. Do we have a pointer? We have A36E on stack. A36E, that's this one. Oh, so it's this call, A37B. Okay, so we're coming from here. So higher up would have been part of the same function, I think. Yeah, then is it this one then? So we have an unconditional return, that's fine. We do have an unconditional jump here though, so I doubt it's before that. Unless we don't jump in this one here, from this one to here below. So perhaps it's this one. So let's see if that's correct. 37B. Okay, let's continue. I do not have control. Oh, wait. That's not good. Like, that's too high, apparently. Wait, 8355. Yeah, that's the top function here. Okay, so that might figure out what we're doing here, though. So where are we? Oh, we're jumping after that. Oh, wait, no. No, it just repositioned itself. We do not return. We do take the jump to A368. That's just not increasing B. Okay. What is in HL? C1EH or? Oh, and we're jumping over our thing here. Okay, so no, it's not. That's too high. Okay. So let's go back here, and let's see if that gets hit. That does not get hit. We have to go here. Yeah. So A360 is indeed on the stack though. So we are being called from this function. Not sure. Okay, and this data changed because it wasn't 8s before, and our map hasn't changed, so it's not the map data, I guess. What's interesting is we are loading the power-ups here and we're saving them somewhere. So let's see what DD4B is, if that's related to our construction mode or saving to disk. DD4B, that's quite low though. That's down here, right? Yeah. That is a bit weird. Or are we storing the pointer? Wait, no, we might be storing the pointer. So we loaded the value or we're loading the value into HL. No, we're loading the pointer into HL, and then we're loading that pointer into DD4B. Or is that what DD4B is pointing to? Yeah, that's D66E, right? Yeah, because this is a pointer. Or are we overriding the pointer? Or wait, so it's D66E. Yeah, we're overriding the pointer. Okay, that's D5F8, which might make sense though. So it's power up related. But we have to save like 5 similar levels, right? So I'm assuming those pointers just get updated, and when we're saving, we're referencing what this pointer points to. And these are the same though, like D87. Oh no, current. Oh no, round 1. Okay, round 1 map data. Of course, round 1 is going to be the base pointer, right? So they're probably all in sequence. D5F8. If we go look, D5F8. Yeah, so we have round 1, 2, and 3. So if we have a pointer to the first entry in the struct, then we can copy all or access all, I guess, just by indexing 0, 1, and 2. What do we have? We have start index. Okay, that's fine. So we were looking at this guy here, I think. yeah, DD4B. So this was the first pointer, and then DD47, that's the pointer before here, is updated with the current map data power-up 1, of which we have none, I think. I can't remember if I put power-ups on this level. I'm loading that. Okay, so we're loading that pointer. Fine, and then 0C in 49. Okay. This one becomes for OC. Right. And then we load the pointer for the sprite pattern table, copy to VRAM. Okay. Right, and then we're doing our routines where we call what we are originally looking at here, right? So what's interesting is that, like, it has to gather the data to save, right? So we've already prepared pointers for the power-ups. That's fine. We are looking now at the sprite pattern table that will be copied to VRAM. I mean, their name is a bit strange, but it's going to be the tiles of the map, I'm assuming, right? So C000. Wait, let me open a new window here. That should be our data, which it is. And question is, are those 8s all this level data though? I mean, there are some FFs in there, and I don't see my 5 hard framers either. Because they should be the same though, like. So this name isn't ideal yet either. Wait, but it's sprites though. Yeah, we don't have any sprites, or I guess Lolo perhaps. So yeah, we might not have any sprites. Now the interesting thing is that we're copying 4 more things that we haven't named yet, right? So we have an inkling of what this could be, but not what C07A is. Oh, I shouldn't have closed that because it's right below that. So C07A. Right. So yeah, they are short structs. So a new one starts here, and then we have one at F4, which is this one. Yeah, or this one. Yeah. So we have 4 pieces of data here, or 5 at least. 1, 2, 3, 4. Well, I mean 1, 2, 3 sequentially, and then there's a gap. I think C16A. Oh, maybe not. No, maybe not. So these do mean something for sure. I'm gonna name these so we can reference them. So C07A, and we can also deduce sizes, right? So I'm assuming that it does start here and end here. Let's see if that's a recognizable value. So let's take the calculator here and let's count. So we are at C07A, right? So that would be, okay, so I'm going to take C07A because we're doing 0 base, right? C07A minus, so and including C000, I mean, that's going to be C7A, of course, which is 22. Perfect, because 122, because 122 is 11 by 11, and we have 11 horizontal blocks and 11 vertical blocks of the map. So this is like perfectly an entire map, right? So, and the only sprite we have defined is, well, we have FF here for some reason, but we have F0 as well. And that could be Lolo sprite here. So let's go look at sprites. F0 means uh, 240. Let's see if we have sprite 240. Not in this mode, of course. Crap. I mean, yeah, it's this one, but there's nothing in there because this level doesn't load any sprites. Okay, let me change these walls out and see what changes here. Because we have like 5 sets of 121 data points, right? So let's see, let's escape this thing for a moment here. And let's go back to our edit mode. Come on. It's a bit confused about that, but sure. So let's see what we can do now, right? Does this change? Right, okay, so we're moving here for some reason now. I don't know why that's the case though. Maybe we are literally editing those blocks down here. Wait, okay, we're doing round 5 though. Let's go to round 1. That's gonna be more, and I'm assuming it's gonna move here. Wait, select round 1. I mean, they are empty though, so I would have assumed it was 0, but apparently not. So yeah, let's go in this mode. Do we change here now? Yes, we do. Absolutely. So this is indeed the sprite index. Like 38 is too, well, no, 38 is 56, but there aren't any sprites though. So I can't really check that, and it's not going to be 56 in the tile viewer, in the tile index here, because that's 116, right? Like 56, is that even possible? Yeah, that's 8, so that's definitely not a tile ID. It is a block ID. Okay, so we can figure that out. So 38 is a emerald framer, right? A block, a push block. Let's go see in the password thing, the password selection, what the index of block is. So what did I say? 38? I already forgot it. Yeah, it was 56. Crap, I forgot. 38, which is 56. Okay. What do I need to remember? 56. Oh, no. 56 is way too high. Yeah, that's unfortunate. Because what I was going to say was 56, if we go look at the password entry, we can look at our selected password, right? So yeah, entered password slot 1. If we put a thing in there, now, so see, yeah, I thought it was this index, which is OE, which is 14, but that's not the case. So it has like multiple IDs for the same element. Like in this context, in the password context, an emerald framer, like the push block, is 0E. But then when we go to our sprite indexes or whatever, then it's a completely different number. So that's a bit weird. Let's see. Let's look at our sprites here. So yeah, 240 we said, and that's like nothing here. That's way too high. Those aren't used, or I don't think so. Yeah, that's a bit strange what those values are. So we haven't figured that out yet. If we now look in a level what this is, can we change that? I'm not going to change this one because that might be low, but yeah, so that doesn't do anything, right? And it also doesn't block us. And does this change based on level? No, it does not. Okay, so that doesn't change at all. That's weird. Yeah, it doesn't move at all. Like it got reinitialized, but the end result is the same. Wait. Oh, wait. These are sprite pattern tables, of course. These, yeah. These aren't sprite indexes, but it's the pattern table, obviously, right? So this is, I think this is this. It's this table, right? So pattern 0. I mean, it doesn't show me any details about it though. So what is Lolo here? Sprite 27, 28. Does that make sense? Where is Lolo? Facing forward. Well, no, that's 152. But yeah, so I mean, this doesn't change anything here though, unless I maybe perhaps reload. No, it doesn't change anything. But yeah, this is a pattern table, not sprite indexes. And that makes sense because those sprite pattern tables would be the same for all the levels, right? It's only when we're in a different context that the sprites are different. Right. Yeah, so if we now look at the sprite table, there's nothing there, and that does make sense because it's pretty much empty now as well here. I mean, we have 38s in here now. Wait, no. Now we do have well, no, it is though, because the 38s are the emerald blocks, right? Yeah. And they are in the shape of what is written, what is painted here, right? That's like the thing. Yeah. So they are block coordinates, but then why does it not paint more? I guess this was like a buffer though. Like this doesn't necessarily get copied over. Like it that wait, where does it start here? I mean, yeah, it is like literally. Oh, okay, and brick is 0. Like it's overwriting my values, but it's not getting copied into VRAM. Wait, so let's look at the VRAM. Because it has to be here too, though. It's not going to be at the same position, of course. Like it's not going to be at C00, I guess. So I don't know where that is being copied. Do I see that here? No, there was no out here. No, I can't see that. Wait, can I see that in the registers here? Yeah, it's these guys, right? So we were looking at the sprite pattern table, which starts at 3800, okay? So here in 3800, that should be a copy of that. Okay, can I not make this smaller? No. Okay, it's starting again with the stupid. Of course, once these windows overlap, they get messed up, and I can't close them anymore. And okay, great, excellent. Oh, and now they are not responsive at all anymore, and I can't close this either because, I mean, I can close this one, but I think it opens a new one, right? Yeah, of course it does. So 3800. Yeah, so do we see something change now when we put stuff in here? No, so it's not exactly copied here verbatim. That's unfortunate. Yeah. Hmm. What surprises me is that like this sprite pattern table, um, like they are values like if you see it changes here, right? So these are values that and the last one here, these are values that change. In other words, they have where's the last one? Oh, it's down here. Wait, it's bigger than I thought. Okay, oh no, it's not here, it's this one. Okay, so this is the last one and that's the next one. Okay, sure. Like over here now we have a direct mapping to the block and an index into the sprite table, right? To the variable sprite pattern table. But then if we go look at the sprite pattern table in the levels, this value here, it doesn't change. And that's what's confusing me. That's right, if we load a level here. Okay, so it does change, of course, but like we have our 38s, I guess, which are these two blocks. Where are they? I mean, like nothing moves, right? Nothing is removed. I'm gonna remove or move the block, and nothing changes here. So I'm not sure why that only works for. Yeah, nothing is changing. Why that works for construction mode and not for this, like in game. That's super weird. Yeah, I don't really understand that, but fine. So we were looking at the save data, right? If I come back to what we were starting at here, and that got triggered. Where is it? Oh yeah, we have to go to construction mode again, of course. And then we were in. Okay, can I not close you? No, I have to restart, I guess. Okay, I have to restart. Okay, now I can close it. And then we were going to save. Yeah. And it started from 5 or something, 4 or 7 was it? We don't have, of course, we don't have that anymore because we restarted. Yeah, it's hard to see what triggers or how it's compressed though. Like that's reverse engineering. That's going to be tough. Because these values don't make sense. Like it's too short, right? There's not enough information here. I mean, there is, but it's in a compressed form, right? So I guess we'll have to look at that another time. Okay, I do want to check one more thing. If I didn't do that already, is the setting the power-ups. So saving again doesn't change anything. Well, briefly, but which is also weird. I mean, it is hanging on it though. And I don't want to see if something, and it's going to be hard to spot because it flickers, of course. Right, so I have our power-ups. I'm not going to be able to see that. And if they are compressed, then it's going to be included in the compression though, so I won't be able to see what changes, right? So, I mean, I can press save, but yeah, I can't see the difference between those. So that's fine, I guess. Sure, so what else do we have? Yeah, these guys were being written, as I could see here, around this area. I don't have a breakpoint anymore. So we don't really know what that one does. Yeah, and for the rest, we don't have anything that we can see changing here. I mean, this is curious too, though, these FFs here. It might have something to do with the list of files, though. If you look here, there's this files thing. And of course, because I don't have a disk attached, I can't see what happens when I do that. I mean, nothing changes, right? So, but yeah, I'm assuming this could be a name or a list of file names or something that's then shown on screen. But yeah, I have to install the thing first before I can test it out. Install the disk drive. All right. So what we didn't figure out was where the levels are stored in memory, though. I can search. I mean, I can put in a easy thing to search by clearing the level, right? By by doing this. And if you put something like rows of stuff, then we have patterns we can detect. That's going to be 0, so I'm not going to do that. Let's just, well, I can do plain water. Oh, I thought that was the exit. It apparently isn't. And let's get some other stuff here. Oh, right, we have limited amount of those. That's fine. How many can we get of these? That's unlimited, right? And then let's put some blocks in. And then some walls as well. Okay. So now if we go look at level map, what is map data? Pointers to level data 625. Okay, 65.6. That's going to be pointing towards where the levels are stored in the ROM. I wonder if that now changes. So D5F8. I'm going to open a new window here. I'm going to look at D5F8. D5F8. No, please don't. Of course, I closed the wrong one. D5F8. Okay, that points to here, right? So that's round 1 map data. Okay. Oh, and interestingly, this looks to be the same compressed form because it's way too little information for 121 bytes worth of block data, right? So this is just the level data or the first level stored in the ROM, right? So this has to be, it's loaded from this, and the second level starts here. The second round starts here. So we have this amount of bytes that specifies the level. Yeah, so that perhaps is the same state. We can verify that though by saving the standard level and see whether that's whether that corresponds. So does this change now? 65.6 we have to open. Okay, keeps putting it in there. Right, that's our pointer. Does this now change when we escape? No, it does not. So how does it know what to load? That's the question. I'm going to put a watch point on this one, and I doubt it's going to break. It's a read memory watch point, of course, because it shouldn't load this pointer now. It should. Okay, it did. Okay, so has that changed? D5 F8. Yes. That's weird. I mean, you see the repetition here, right? That's my level. That's the repetitive stuff that's being put in here. That implies, though, that round 1 map data is not. This isn't a ROM then, like the hard-coded ROM values, because they're overwritten. And if you wait, can you restore? I mean, I guess you can't, right? If you use the construction mode and you change levels 1 through 5, I don't think you can get them back. So maybe they are indeed overwritten. Yeah. Okay, so there is no separate storage for the construction levels. They're just gone now. Yeah, you can't. You have to reset the console. You have to reset the computer, or yeah, turn off the power to reset those values. That does make sense then. Okay. So yeah, here we are the level. Here we are loading the level. What's interesting though is that these are 3 power-ups, but I don't think we have any in this level. Oh yeah, we do. Did I add that? I can't remember. Perhaps I did. Yeah. So it overrides the level completely. Okay. So we can figure out the compression algorithm, so to say, from this from the level data itself as well. Okay, that's good to know. Now I'm going to reset and I'm going to compare. So this should reset to, yeah, so this resets to the level. I'm going to compare this to what is written out on disk, if that's what it is actually. Where was that? Yeah, it was around here, right? So I think it was, yeah, it's this data here. So I want to compare that. Yeah. So I'm going to escape. Now we've overwritten this. It already made some changes. And is it the same? It is not. Wait, where did it start? Yeah, I was assuming that this piece of data was going to be the exact same as what was in here, which is the thing that got saved. Wait, what? Why is it now doing type B demo? Is that random? I don't remember that being the case. I mean, it's the exact same pattern you have to go through though. I mean, I guess we can see that if it's a different play mode for demo, if he picks up the chicken at the end. Oh no, the chicken is already exit, so he has to pick it up. But yeah. So now if I save, yeah, so these values don't change, but they are not the same, unless I'm not looking correctly here. So what we have here is like the configuration of round 1, right? So it has to be saved exactly to disk as it is here. So that and the ROM data should be the same, but I don't see them as being similar. Wait, so 0828, no, we need 20 OB. So either this isn't the saved disk data, or it's a different algorithm, but why would it be different, right? Like if you have to have a thing to read this, and a separate thing to like decode and read this, that wouldn't make sense. So, and how much data do we have here? Let's calculate that. We go from, that's, okay, so that's Lolo start index, that's the exitor index, and I guess the level, so we have 3 up, okay. So the data starts from here, I assume. Oh, that's also curious. Why is there an extra 0 here? Because we have round 1, map data power up 1, and we have round 2, map data power up 1. I might have made a mistake here, that this is something else here. Because the start index, like there's 3 power-ups, and there's an unknown, and then we have Lolo start index and the exitor index. But then here, that missing thing isn't here. So I might have made a mistake there. Let's see from here to here, right? So D622 minus D5FE. That's 36 bytes. I do want to be sure that it's the same, that it's actually level 1 though. So let's see if I don't want to change Lolo's position, right? I mean, it's gonna mess up. Okay, so it starts with AFOFOB, right? So AFOFOB 0709. Okay, so I'm copying a couple bytes and I'm going to reload level 1. It might, of course, override now because I'm in construction mode. Did it? Yes, it did, of course. AFOFOB. I'm erasing Lolo, so it's not going to be happy about that, though. AFOF OB. Oops. OB 0709. So it's going to crash now, I guess, because there's no Lolo anymore in the level. But I want to make sure that, okay, it's crashing already. Yeah, okay, that thing is on, that's fine. Oh yeah, no, the Lolo starting index was, of course, defined separately, sure. So it is definitely the markup of the level, but okay, first of all, let's look at this one. That bothers me, that there is an extra one here that we don't have in the next one. So add watch point. I'll also, let me put 82 in there, right? To see if that changes anything. Yes, it does. So I'm just wrong. Yeah, this is wrong. The start index is this, and that's the exit door index is 85. So let me change that one as well. Oh, wait. I have an algorithm for this though. Yeah, it's this, right? To convert an XY position to a tile position, I can do that. Can I do the reverse though? Because this is the result. So yeah, this is the result though. It is as simple as that. I didn't even see that. It's simply the XY coordinate as in X8, Y2. Is it that simple? I think it is. Yeah, because C8, so we started from 0, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. And at Y we are on 2, so 82, the 2 being 0, 1, 2. And that was 0, right? Because 0 is this, 0, 0 is this. Okay, it is as simple as that. But the address is wrong. Lolo start index. Round 1, this should be B and C. Yeah, so these values need to shift up 1 to the left. Okay. And it is indeed XY, as in, that's crazy. Wait, and we can go to 15, right? We only need to go to 11, of course. But yeah, so let me put the door just in front of his face. That would make it 83, right? So let's stop. And reload the level. So now the exit door is right in front of his face. That's quite interesting. For example, 0x25 equals x2 y5, of course, within 11 by 11 grid, 0 paste. Right, that's so easy. I'm gonna copy this. But it only applies to like an index, right? So that doesn't apply to the rest, I think, because that would be, that's data, right? Like, no. Okay, so let's remove the first one. I mean, if it shows a wall here now, I'm confused then. Oh, it crashes on that. Can't do that. Wait, did it override this stuff? No, no, right? Oh yeah, no, 0 is the first. Yeah, it's A5 here. Yeah, it can't handle that at all. Yeah, it crashes on that. So let's see what reads that. At watch point. Yeah, it's not this one. A read. And let's start the first level. Okay, here we are. So we get this as a pointer. So we're looking at D5FD, which is in HL. And we're loading the value into AF. Okay, so we're leading A5 is being read. That's the first one here. That's correct. Okay, we're immediately adding stuff. Okay, sure. I'm guessing this is the mathematics that converts it, like decompresses the thing, right? We're using an unknown here. That's fine. And we have to jump to A517. This is our loop. Oh, we're loading A into B. So A5 might be a counter now. What is A5? 165. Could this be a length? No, because the total length was 132 or something. That's too much. Right? Oh no, wait, we're adding it. Wait, we're adding it. So that becomes 25. And then we're putting that into B. And 25 is, of course, 2 times 16 plus 5. Nope, not my trash. Well, it's 37. Oh, wait. That's interesting. Because that's one more than we had, right? I mean, I might have made a mistake with the zero basing. Right. So this might be a length. So it's 25, right? That's hex decimal is 37. So 16, 32, 3, 4, 5, 6, 7. Exactly. Yes. This is 37 bytes. So that's the length. But why do we store this as a thing we have to AND with 7F though? So if you look at 7F, that means we're dropping the top bit. So we're using the top bit probably for something else. But like the lowest 7 bits of this number is the length of data that we have. That's why it crashed when I put 0 here, like it couldn't read anything, so that makes sense as well. So that means that the level lengths here are different sizes, and that makes sense because it always starts with 3 power-ups, right? But the first levels don't really have power-ups. So that does imply that we can see the boundaries here by looking at 3 zeros. And indeed, the second level starts with 3 zeros, because the second level doesn't have any power-ups either. The third level could start here. But then you see the fourth level is here. That doesn't make sense lengthwise, so there should be either it's variable length or something else is going on. But now that we figured out that the first byte here is the length of, or the amount of bytes remaining in that we have to read, then it does make sense, because if you look, that's level 1, 2, 3. The third level is very short. Why is it very short? Because that's the level with the 4 goals and nothing else, pretty much, right? So if we go look, we can come back to this, that's fine. So if we look at level 3 is this one, right? It contains very little data, so that compresses way more, so we don't need as much between from here to here, right? Okay, that does make sense. So D5FD, round 1. So this is not map data though, this is round 1. Well, I mean, yeah, no, let's leave that. That would be byte length. But drop the most significant, well, drop the top bit. What was it, 07? No, F7. Okay, so that's our byte length. Okay, and then the next one. I mean, I guess I can just watch this one, right? And then we will go to just before level 1. We don't break on that one. Wait, am I? Okay, every time you load a watch point, it removes the... Every time you load a level, it removes the watch points. I think that's a bug though, I have to look at that. It's not a write breakpoint, not a write watch point we have to do. It's a read one, of course, because we're not writing. Okay, break. Good. So we're in the same position, right? I think. Are we? We might be a bit more lower down. Wait. No. Here we were loading. Yeah, we're ending with 7F. So wait, let me first start. See if I can figure out the start of this function, because that would be the load level function, load round. Oh no, we have that one. Load map data into current map data. Okay, sure. Right, and if we go see, yeah. Okay, so the current map data will have that decoded, I think. So D87B, so that's a bit down here. D87B starts with 3 power-up informations, like IDs. And over here, we're actually going to load the level. I'm going to let this go now. And we will see that it gets loaded, not just from these... Wait, why is this not changing? Did we not... So current map data power-ups. And then the 2 start positions, start index and exitor index. And where is our data? Oh, do we not have that? Oh, we don't know the pointer. Oh, okay. So yeah, we only... Wait, that's weird. Or are we putting that in level data? Is it this one, DB61? Yeah, so I think it's this one then. So it converts it to this. But these are tile IDs. So these are the 4 tiles. So 70, 71, 72, 73, I'm assuming. Well, that's also a bit weird, but no, these are walls, right? So these are top and bottom is the same 2 tiles. So we have 70, 71, 70, 71 is like the 4 tiles that make up the entire block. So we're converting that to this. I'm thinking we're writing that there. Okay. I want to go look again at this. So that's our length, right? For level 1, round 1. So let's re-enable and reload the level. No, my keyboard. Well, no, I can F8 to stop. Okay. So yeah, and with F7, this is our length. I don't know why I'm breaking on length again. D5 FE. That's weird because is it a breakpoint or yeah, of course it's a breakpoint. No. Okay, we're at the start. Anyway, never mind. So yeah, that's our length. And we're putting that in B. The B register, of course, is used for if we have a loop to keep our indexer, right? The I variable or whatever that you put your that we loop through. So we're looping like hex 25 times, which is until here, right? So we're loading the value, which is FD now. Well, still the same. Okay, yeah, no, we've right. Now we're taking the top bit. So they're saving the 7 bottom bits are the length, and the top bit is being added out now. We're increasing. Now we're pointing to HL now points to FE being the first byte here. Fine, that's an aside. But now our value here, our A5, we're taking the top bit, right? If you look at the hex or the binary representation of hex 80, that's the top bit, right? That's just the top bit here. And we're doing a conditional jump, so that means something. That's interesting. Do we take this jump? We do not take this jump. The question will be which level will have a 1 in that thing, right? So yeah, never mind. We're not jumping here. We're pushing DE. That's C000. Okay, that's also an interesting number because that's where our tile IDs were, right? Our sprite pattern table IDs. Okay, we're loading OP into A. Oh, and we're saving that into D912. I don't know what that is. That's a hard-coded value that's being read into that. And that's right next to construction mode stuff. Okay. Does it come back? That does come back here though. So we're loading D912 in A and we're subtracting 1 of it. Also a bit weird. And then we're putting it back. So we're doing something. I guess we have to keep track of 2 iteration variables, right? So we have our thing 25 in the B register, which is our loop iterator. But it looks like we have to do something, 11 times as well. And we're storing that in memory. Because yeah, we're putting, But we'll find it out when we're there. Okay, so we are loading now into the first byte of our compressed data, which is 88, right? That's in A now, and we're ending with 07. Okay, so well, actually, it's like 3 bytes 3 byte power-up IDs, and then we have 1 byte for Lolo's starting index, which was, I guess I can copy this information here. And then we have 1 byte for the exit door. And then we have 1 byte data length. And unknown. Um, 7 bottom bits is length. Top bit is unknown. And then we have n bytes level data, right? And then the algorithm is, okay, so you take bytes and OX07. I don't know if I'm being able, if I'm going to be able to write everything out here though. So we're taking the 3 bottom bytes of the 8 here, the rightmost 8, which then becomes 7, of course. So we're checking whether they are set, right? Which they are not for 88. Right, they are not. So the 3 bottom bytes are not set. So this is going to fail, I guess. Yeah, that's 0. That makes sense. We're loading that into C and incrementing it. Okay. So that's either 1 or 2 then. No, because assume it's 4 or something. Yeah, if we do 7 and 4, that's still 4. So it's a number from 0 to 7, and we're adding 1. Does that make sense? So we had 8, and 8 becomes, okay, so that, okay, 8 doesn't have any of the 3 lower bits set, that's fine. But like anything else, like we just add 1, right, to what it is. Okay, so sure. Is bytes and this plus 1. Right, I think that's what that does. Hi, Negforsa, sorry. Okay, so we have that incremented in C, right? This becomes 1 because we had 8. 8 had none of the 3 bottom bits set. And we're loading HL, which now is FE. Did we increment already? No, not yet. So we're reloading 88 into. Okay, now we're gonna take the other ones, I guess. Wait, let me get rid of this. Yeah, again 88 in A, and then we do and with F8. Okay, I have to go look again. F8 is going to be all the rest, I guess. Yeah. So that's the top one, the top 5 bits. but we're probably gonna do something with that. So we're loading, oh no, we're loading that into the E. Oh yeah, well, okay. Into what D, oh, into what D is pointing to. So C000, that was our thing, right? This was the sprite pattern table. Which then was, I mean, it was like 121 bytes of IDs, right? So we're writing this. Sprite pattern table of var2. No, that's just an iterator that probably gets incremented somewhere. Yeah, okay, we'll see. Equals var2. So the top 5 bits are the sprite ID or whatever. Okay. So we're loading that in here, right? So this becomes 88. No, that's not. Wait, why is A still 88 though? Wait, let me check. So we have 88 and F8. Does that make sense? That remains, so 80. Oh wait, of course, yeah. It's the top 5 bits and the 3 bits are ignored. Yeah, that remains 88. So this becomes 88, sure. Did that happened? Yes. Okay, then push PC, that's fine. And we're loading B, which is 11. We're exchanging some registers, that's fine. Okay, we're adding HL and BC, so we have an offset now. So we're now putting at COOB. Sure. And exchanging again, that's also fine. Popping BC, we're restoring BC, which was 2501, the thing we calculated, okay. And now we have our little counter, right? So we're loading the 12 counter, or 11 was it? Yeah, 11. And we're doing sub 1, which makes it A, okay. That would jump if it's 0, but it's not yet. So we're not escaping this little loop. And then we're writing, we're decrementing our little counter here, our extra counter. So we're doing something 11 times as well. Okay, we decrement C, which is the bottom of our loop. So we processed this byte, this one, and we're going to the next, because now we have 24 in our B register. Oh no, a C register. Oh, no, that's not B, it's C. Okay, so now if var1 was not 0, we would have done something. Which would have been that jump, but seeing as we don't take that jump, we don't really know what's going on with that in particular. Okay, we're increasing. Okay, so we're not doing that. Increasing HL. Now we're pointing to the next byte. Yeah, which is 0F. And question is, do we now do the same? We're jumping to A517. So that's our loop return. A517 is up here. Yeah, so we're ending with 07, taking, okay, so we're doing this routine for every byte. And if, like, all we have to figure out is this, right? What happens if that actually is the case? If the bottom 3 bits are something other than 0, is this the case for the next one here? Yes, it is. Because it's OF, right? F has the 4 bottom bits set. So let's do the next one, and then we'll take a look. So we're loading OF into the accumulator. We're checking the 4 bottom bits. That's this one. We're loading, so that becomes 7, right? Because, yeah, that does make sense. They're all set, and we're only taking the bottom 3. We're loading that into C, and we're increasing. So we're doing the +1 here. That becomes 8. So we're doing a mapping from 0 to 7 to from 0 to 7 to 1 to 8. We're loading the same value again, our 0f, which is what we're handling here, right? This one. And now we're looking at the top bit, which is unset, right? We're loading that into, okay, we're loading that in, wait, what? Oh, no, the top 5, the top 5, we're doing this, right? The top 5 bits, they were 8, right? Because it's 4 zeros, a 1 and 3 zeros. This one, well, ANDed, right? ANDed with F8. Wait, let me double check. So we have OF and F8 becomes 8 because OF is of course only the 4 bottoms are set, and we're taking the top 5, meaning we drop the bottom 3, so that becomes 8. Yes. Which we have written now to COOB here, this one here. That's very interesting. I need to figure out how this sprite pattern table works, because these two are, well, this is the first one and this is the second one. That doesn't really make sense to me, because they are like position 1 and 2. I'm assuming these are in order, right? For like you're doing right to left, left to right, top to bottom, filling in all the blocks, but apparently not, unless that's what the algorithm is, of course. Like, I don't know. Okay, so we've done this. This I is incorrect because we're doing strange things with that, though. Okay, so again, we're loading 11 in here, and I'm assuming we're incrementing our pointer, little pointer again, though, which would mean that, yeah, we're adding B again, and now it becomes CO16, which is this one. So we're adding 11 every time. So actually we start with I equals 0, and then we do I plus equals 11 for some reason. And then we decrement our, oh yeah, I didn't note that down. But so where did we start here? Oh, B got written to, yeah. So we have another variable, which is counter is 11, was it? B is 11, yes. And then what we also do is counter minus minus, so decrement counter. Okay. Oh, no. So it's not var 1 here. Oh, or was it? Oh, no, there's 2 escapes here. Yeah. Of course. So, like, we're doing if counter equals 0 is do something, but then we also check var 1, right? So we're saving our little counter. We're decrementing C, which is from 8 to 7. Wait, and we didn't. Yeah. Now we are jumping as we figured, right? So A51F is our target. Oh, we're going higher up again. Jump to A51F. Okay, so where was our normal return? A517. Oh, we're looping within the loop. Okay. we are writing again the same value to our sprite pattern table here. Yeah, that's what it looks like. Okay, it is time to stop though. I'm gonna pick this up next time. Because yeah, I do have to go eat. So thanks for watching, and until next time,